What used to be one person's hard work has now become another person's pleasure. This 70-foot steam barge, built to carry coal in times before motorways, used to provide a living for a family. Now it's used for enjoyment, as a hobby.
How many of us have the time to really enjoy our leisure? In the future, we're all going to have a lot more leisure. And there will be questions asked as to how we spend our spare time.
Maybe you've always wanted to spend more time at your hobby or learn a new craft. There are so many crafts and skills to be experienced, it's difficult to know where to start. So while we're enjoying our leisure time, how will the work get done?
You've all heard of robots. It's an in word these days. Some people write stories in newspapers about robots taking over the world and doing everything, while we just sit around and do nothing. Certainly these cars are being welded together without people. But if you think about it, a robot is just another tool or machine which has been designed to help industry. Craft, design and technology has created robots. This one was built in Britain, and like all robots, it can do nothing until it is told what to do.
Look at all these moving parts. Will they break or wear out? Will the electronics fail? How long can a robot perform? Is it reliable? To answer all these questions, this robot is on a destruction test. It's been running now continuously for over 6 months. A detailed study of its performance can help develop even more reliable machines by identifying any weak components.
All robots are at present designed and built by us humans. First, you have to decide what tasks you want the robot to do and where. For example, will the robot come into contact with heat or with acid or any other corrosive fluids? All these and many other decisions have to be worked out during the design stages. So eventually, a set of design drawings are produced for the manufacture of the robots. And that's what's happening here now, in this drawing office.
That is the datum, because the thing has to be concentric to that, and no other facet. I think we could be on a winner then.
Where is his diameter for?
So what will the robot be used for? Some will be required to perform only one task forever. Others may have a few different jobs to do. The designers make their decisions according to the needs of the people who want robot equipment, and their decisions affect every part. At the same time as the robot hardware is being designed, the electrical control systems and the computer control programs are being developed here. As you can see, they use silicone chips in the circuit board, which makes up the control and memory systems of the robot's computer. This memory contains all the instructions to control the movements the robot makes, and it's a permanent memory. This is called the Research and Development Department of Hall Automation Limited, part of GEC, which is one of Britain's leading manufacturers and developers of robot equipment. So let's meet Hal, the robot's computer. But without this, it can do nothing.
So, we're back to computers again. To program the robot, to tell it what to do and when to do it. For every modern robot, there's another machine in the background somewhere. A kind of brain controlling every move it makes. Once the design has been completed, the electronics have to be assembled. And that's what's happening here.
To make any machine work, you need power of some sort. In this case, electrical power. Apart from power to drive motors, you need signals or pulses to give instructions. And for every move the robot has to do, there's a set of circuits to carry the signals. Then you have the muscles, or the mechanical parts that do the work. Much of the hard work in a robot is just moving or levering its own weight. Then there's the work it was designed to do. Mechanical components are put together in this part of the factory. Remember, we saw this part, one of the elbows being developed earlier on. Later, we'll see it in action, but first, let's have a look at how it's assembled. If it weren't for the fact that all robots are different because they have different jobs to do, this assembly could be carried out by another robot. All parts in this elbow have been specially designed to do certain tasks. Bearings and shafts, all fitting together perfectly. Each engineered and machined carefully to exact measurements. A hair thickness too much or too little, and some part will wear out and cause a breakdown. That could be dangerous. A robot is a good example of the combining of craft, design and technology. The people who make these parts have a long tradition of care and accuracy. In most cases, unnoticed, except when something goes wrong. Few people realize the amount of unseen background work that goes into any set of engineering parts. Now the power systems are connected, ready to provide strength and control when ordered by the computer.
Eventually, the mechanical and the electrical components come together for the final assembly. The electrical systems carry the control messages to the mechanical parts, rather like the nervous system working with the muscles in our own bodies.
But once built, the robot must be tested to make sure it can do all the things it was designed to do. Testing starts here, with the electronics, making sure the circuits are correct and the electronics functioning properly to give the correct instructions to the mechanical parts. This machine has been programmed to spray paint, a job that requires it to twist and turn in many directions. Now it's being watched to see if there are any weaknesses. How would you like to do that job for 6 months without a break?
This isn't a two-armed robot. This is the working arm, the arm that will have to do all the work. And this is the teaching arm. The working arm is far too heavy to move. It has to be strong because it might have to lift heavy weights. The teaching arm is much lighter. Let me show you how to teach a robot. First, the computer must be told to program or record all the instructions from the teaching arm. Everything the teaching arm is told to do will be exactly reproduced by the work arm. Of course, this is a big robot designed for heavy work, not an office job. But even so, it might be ordered to do anything in its lifetime. Another part of the computer memory has now stored my instructions. So I just push playback. And let's see what happens.
Now the heavy arm takes over. Take 100 lines for untidy copying. Then what can you expect from a robot if the silly human didn't fix the pen properly? Oh. Okay. This robot has been designed specially for schools. In fact, you can build it yourself from a kit. You can program it to do many things, and you might even get it to play chess.
Some of you may find yourselves designing and making robots. Certainly most of us will enjoy the benefits they bring. There was a time when canals and narrowboats were part of the industrial scene in Britain. Just think how it has changed since those times 150 years ago. Think how life has changed in the last 10 years, and how many things will be different in just 5 years from now.
This won't take over completely, but the future's going to mean new designs because of more technology and many more skills to organize our lives. Checkmate.